Okay, welcome everyone to Quality Improvement Methods, and today we'll talk about the control phase, which is our last phase in the DMAIC framework. The control phase has other tools than the one we will talk about them today. Those tools being discussed in the Six Sigma review recorded sessions in the channel, and also some of the tools those covered in the measure phase, like control charts, run charts, can be used here in the control phase. In addition to the one we have talked about in the previous session, in the improve phase, Pokeyoke, or the mistake proving, one of the approaches can be implemented, which is the control. And in the control itself, you can use that concept in the control phase to make sure that the system is preventing defects from occurring, as well as check sheet, like sample of the one of the tools that is very simple to have check sheet to make sure that all the actions needed to be done is being implemented correctly. Um, we will continue today with different tools. We will start with a new tool called radar chart. The radar chart, or in Arabic, radar. Uh, the radar chart, it's a tool that is graphically representing the performance of variables or factors you have. Is very useful tool to translate those numbers in tables into a graph that easy to detect where is the strength and weaknesses, and also it define the full performance and overall performance. It's a polar graph and is very useful in the cases only where you need that performance indicators to be represented at a given time, at a snapshot, but is different than, for example, the run chart or control chart, which is what is providing the performance or the measures over a period of time, not at a certain point of time, over a period of time, so you can detect and trace the historical data. This is maybe one of the limitation of the radar chart, which is it's working on a point of time or in a certain point of time. The benefits here is listed. It highlights the strength and the weakness of the process or the product, or even the team worker or the human resources you have in the organization, as we will see in the example. Define full performance in each category. Also, it acts as a focal point to capture and review the different perception of all stakeholders. It gives rates from 1 to 5, or you can put low, high. This is where you have your room for implementation. You can use either a scale from 1 to 5 or low to high. Let's see an example. It's very simple. This is an example of annual appraisal carried on for two employees, Ryan and Khalid. Ryan and Khalid, they are two employees, and the annual appraisal اللي هو التقييم السنوي is being conducted based on those criteria is given here. Communication, punctuality, communication, التواصل أو عمليات التواصل سواء either verbal or written. Punctuality here الانضباط, being precise in doing the job. Problem solving, leadership, technical knowledge, and years of professional experience. This is very good example for you as students, and soon you will be fresh graduates. Always in the organization, you will be evaluated on similar to those criterions. You are not just going to be evaluated based on just solving problems and going to work during the 8 hours of the operations. That's why we focus here in the projects and even in this project presentations on one of those criteria, and is very important, which is the communication. Punctuality in our case being on time in the deliverables, submit what was requested from you. I know most of you know that the problem solving is very important, and as engineers this is considered to be your maybe the ultimate objective, to solve problems. Leadership, and here this is a difference between students and others among them, who has leadership skills and who trained to improve his leadership skills. Technical knowledge, and this is part of your knowledge in the discipline. So these criterions for being implemented for Ryan and Khalid for their annual appraisal. And the data was given here in this table. The communication, the scale was used from 1 to 5, where 1 is low and 5 is high. We have here the communication rates for each one of them. Then we have the experience. We have leadership, problem solving, punctuality, technical knowledge for each one of the employee. And instead of looking to this table, and imagine if this table has many categories and also you have many employees here, this can be applied, by the way, to any other, for example, the process, KPI of the organizations, any applicable case where you would like to see the performance in this manner. This is what we call the radar chart. The radar chart, by just looking to the figure, you can tell that the blue, which is Ryan, has more significant criterions to score in a high grade scale, close to which is the highest 5. Where we see Khalid is in the average scale, because these points here representing, for example, the experience here, you can see the point, it's intersecting with the 5 scale. So he has, in the experience, as you can see, he has 5. So how you interpret those numbers, or how you translate them from the table, the leadership, punctuality, problem solving. Problem solving, we have, if you would like to see the number, so you see where is the line, it's intersecting with the point, and it's 3 here. So if we go to the problem solving, and we will see it's 3 for both of them. We see easily Ryan is lack in the communication, that's why he scored 1, whereas Khalid, he scored 4 in the communication. So this is how you interpret the radar chart and how you develop the radar chart. You can use Excel. Here is how you do it in the Excel. You can have the same data we have from the example. You go to insert here, and then from insert you select this tabs, and it will have plenty of charts here, and then you can scroll down to see the radar chart. It's placed at the end. There are 3 different versions, work the same, give the same information. It's just different layout. You can select the chart from here and automatically will be appeared after you select the data. You have to select the data first and then go insert and then go to the table and go, to the figure, and then select the radar chart, and it will automatically be placed on the sheet. This was an example for the radar chart, useful tool for graphical representation of the performance, and it can also compare between several factors, so you can make judgment in terms of the strength, weaknesses for those factors, like we had for 2 different employees. Moving on with another new tool, and this is very good tool, and It's useful to be implemented along with after you do the SIPOC and the process flow. It's useful to do it. Activity network diagram. The unique about this tool, it helps you to determine and monitor the efficient or the most efficient path in the process or in the sequence of steps you have to complete the project. For example, you have a task to be done or a project to be completed, and you have sequence of tasks to be completed. So to trace these tasks and to find the critical path for them, it's very helpful to find where is also the bottleneck in this sequence of tasks. It also help you to visualize the problem or visualize the major tasks, so you can pay attention to them and can focus on them. Also provide and facilitate review and adjust for both resources and schedules for specific tasks. So you can think about those tasks are in a critical position in the sequence, so you can improve their resources to be processed faster, or to reduce maybe from others where you have two more resources and that task doesn't need to. All that can be done visually, and this is the good thing about it. Maybe the example will give you an idea how this looks and how we can implement the activity network diagram. You can apply it to your case on a capstone project, or maybe your study plan flowchart. The study plan flowchart has activity network diagram, where courses need to be taken in a sequence. You have to finish the first year, then you go to the second year until the fifth year. And some of those courses are prerequisite to each other. So you cannot proceed to one of the other courses in the third year if you have not completed certain courses in the second year. Maybe give you an example. One of the courses in the IE study plan, which is IE 203, Introduction to IE. And this course has two prerequisites from the previous semester that comes prior to that course, which is the engineering design and mathematics calculus 2. So if you have not completed those two courses, you will not be eligible to take this course. And that course is another prerequisite to others. So this is how the activity network diagram see where is the critical path. So it tells you from the beginning, those are key courses, you have to take them, and if you miss them, you will not be able to continue in the study plan. I believe it was not the math, I think the statistic and engineering design. So whatever was the courses, but maybe you get the idea when you have multiple prerequisites for a course, and then that course is a prerequisite for others, and so on. This is similar, an example for writing a project. For example, your capstone project now, you have sequence of activities. You have to search for a topic, you have to search for an advisor, and then you have to fill forms and submit them to be accepted. Then you do the first phase of the project, which is 491, and in that phase you have some deliverables to be done, like writing the report, which includes different phases: introduction, literature review, methodology. You have to do or conduct presentation. The report has to be submitted period the presentation of time for the capstone committee to review it and give you the feedback. Also, the report has to be submitted period the presentation for checking the plagiarism in the report. And all that, it's a sequence of activities. You can think about them and list them, or replace those letters here with the description that you would like to break down your project. For example, activity A could be finding a topic and advisor. Activity B could be filling the forms and submit it to the chairman. Activity C is maybe working on the introduction and the literature. D, so on. until you finish and submit or give the presentation or present your work at the end. This is what the activity can, you can have an additional column here, describe each activity of those, and it has to be one single activity, not multiple that needed to be done prerequisite to each other. The predecessor, which is the step, has to be done previous, like the prerequisite, period to this activity. For example, the activity B has to be completed after activity A is completed. That's why we have the activity A in the predecessor column, and activity A does not have any because it's the first step. So the first step didn't need any period activity to be completed to start it. So that's why we have dash here or none here. That means this activity does not require any activities period to it. The duration is the time needed for each activity. Now, for example, activity A needs 3 weeks. Now, the duration of time, it can vary depending on the project. It could be quarters of a year or days or years. Now, depending on the project, this can be changed. Again, you can add column here and describe each single activity here, or you can have them in separate table, just for the simplicity where you can look. When you see activity like that, G has 2 activities listed next to them, that's mean those 2 activities are needed to be completed before you can start activity G. And this is similar when we talked about the course of the IE 203, when that course has a prerequisite, which is the statistic, I believe, and the engineering design. So you can consider activity G is IE 203, and statistic is D, and engineering design is E as a predecessor. Those has to be completed. You cannot proceed and start with G if you have not finished them. And the duration of time here is for G, not for those 2, because those already, D and E, they have their own duration of time. Now, this is how is the information given, or how you establish the table from the beginning so you can proceed and draw the activity network diagram. The activity network diagram is very simple, but it follows certain steps, and we will explain those steps now in the coming slides. So please pay attention, have your pencil and your calculator and blank sheet so you can follow and draw and follow with me in terms of the calculation and the drawing. The first step you will do is to draw the activity network diagram. How you proceed in drawing the activity network diagram is by starting from the beginning of the table here, and you start with the first activity. In our case here, we have the first activity is A. So you start with the A here as the beginning, and then you look after that, the next activity you have is B, and the activity need to be completed in order to start the B is A. So you start, do the B, and you draw an arrow from A to B. That tells you A first, and then you can start B. Then you move on. We have C here, which is another activity cannot be completed until we complete A. So you will have C drawing here, and also you will draw an arrow from A to C to tells you that you have to finish A, then you move to C. Then we move on in the activity and we have D. And D has to be started after the completion of B. Then you draw D after B, and then the same you will draw the arrow from B to D. So on, we move on until, for example, we get to G, because here we have a unique case. We have G where it cannot be started before you complete D and E. And in this case, when you draw the G, you will have two arrows coming to the G, one from D and one from E. That tells you those need to be completed before you start with G. Okay, until we get to the H, which is also the same, has two tasks or two activities need to be completed, which are the F and G. So we write, or you put a node if you want, like that, a circle, or you can just type the letter if you want, and then you give the letters, the arrows that from the task need to be completed before you proceed with the H, which are they in this case, the F and G. It's very simple. This is the first step you do. You draw the activity network here. We still have not solved the problem. We are just drawing now the activity, and now we will start to analyze those values and put them in the right place and do our calculation to find the critical path. In order to do that, we have to develop this small table. This is very important table. We will use it instead of those letters. So we will replace those letters with this table. For every letter, we will replace it with the same table. It has 3 rows and 3 cells for 2 rows. The first cell here on the left top corner is EST, which is the early start time, meaning that the earliest start time for the activity that you are going to work on. The activity, you will replace it with the letter that you are placing the table on. For example, you will place the table here for A, so you will put the activity A. The duration is the duration of time listed here in this table. The duration is the time listed in this table. So the activity A, it will be placed here, and the duration is 3 for this case of A. EFT stands for the early finish time. We will come to those and how we calculate them. The LFT is the late finish time, is the maximum time where you can finish that task or that activity. The LST refers to the late start time, which means the maximum or the latest time you can start this activity. Let's see how we replace those letters with these letters with this table. So let's move on the next slide here. Now we have them are placed instead of the letters, and the letters are placed where the activity cell is highlighted. Here is the activity cell. Here where you write the activity letter, and you replace the letter with this matrix, or you can call it the table, and you write the duration for each activity as it's given from the table. Okay? Now, how we calculate those values, early start time, late start time, early finish time and late finish time. How we do that? So let's follow the steps now here. The first step, you start from the left here, the first node you have, and you move on until the right node. So you move with the flow of the diagram, starting from the left. So you start from the first point and you move to the last point. This is how we will move. So we start with the first one here, which is the activity A. The early start time, since it's the first step or first activity need to be done, the early start time considered to be is 0. Why? Because it's the first step. There is nothing prior to that step. And the early finish time, in this case for the that activity, considered to be 3, because it's the given duration that from the table. So we write 0 as an early start time and 3 as early finish time. Moving on, now we have 2 cells or 2 activities coming after the activity A. How we will proceed? You can proceed with either one because you will do the other anyway. So let's say we are going to do this. What you are going to do, the early start time, it will be directed coming from the previous cell. So you will place 3 here and you will place 3 here, because both of them are depending on activity A, which is the early finish time for activity A is 3. So you transfer this 3 into the 2 cells as the early start time. Now, what about the early finish time for activity B? What you do is you add this 3 to the 4 to write the activity, the early finish time. So our case will be 3 plus 4, which is equal to 7. That will be the early finish time for activity B. And for activity C, 3 plus 2, it will be 5. So that will be the early finish time for activity C. Now the 7 here will be transferred to the next activity or to the followed activity. We call it successor, as we will see later. Then we will copy that to here. So that will be the 7 as the early start time for activity D. And again, how we calculate the early finish time for activity D, we will add 7 plus 5, which is 12. So we will have 12 here. Now, before we move on to G, G has 2 predecessors or prerequisites activities previous to activity G. So we cannot now start with activity G until we finish E. So let's go down here and finish this branch until we come to that point. Now, for activity C, we already have the early finish time. It will be transferred to the next activities. So it will be 5 here, and it will be 5 here, 5 for E and 5 for F. Adding 5 plus 1, it will be 6, and adding 5 plus 2, it will be 7. So we completed activity E and F in terms of the early finish time. Now we can proceed with activity G. How we can, or which one we select? We have 2 different values coming as an early finish time, from one from E and one from D. In this case, you select the largest one. The highest one you selected. So in our case, we will select the 12, not the 6. And the reason is because if you select the 6, you cannot complete, or you start G and you have not completed D yet, because D will require longer time. That's exactly when a student He finished one of the prerequisite and he didn't finish the other, and he wants to register for the second class, the second course. So this is just to give me a similar example how this works. So we select the largest number. How also now we were going to add 12 plus 4, which is 16. So we will type 16 here as early finish time for activity G. Now, moving to the last activity, which is H, we add, we compare the two early finish time for F and G. Again, we will select the largest one. In this case, also we'll select the 16, and 16 plus 3 will equal to 19. So now we completed the first step of the activity network diagram. Now we have done the first round only. We started from the first node here until the last node here, from the first activity A to the last activity H. Now we will work on the opposite direction. We will go back from activity H, which is the last activity, into the first activity, which is A. We will do subtraction, and we will show now in this slide how we will move on. We carried the same values here in this slide, so we will move on. How we will proceed? In proceeding on the second round, which is the right to left direction, to complete the activity network diagram, you need to have the late finish time or the latest finish time to be placed in order to calculate what? To calculate the late starting time. Now we have the early start time, we have the early finish time, we have the duration. We need to find the latest finish time and the latest start time. So doing that will require from us we go backward. In this case, when we do from the first, which is the last activity here, the latest finish time, it will be placed as is. In this case, it will be the 19. So the early finish time and the late finish time, this is, you cannot move it usually, always and all the time in the last activity. In the period activity, we will see in some points how it will works. Now you have the early finish time is being transferred to the latest finish time. How you will calculate the early start time? Basically by subtracting the latest finish time from the duration. So in this case will be 19 minus 3, so it will be 16. So we type 16 here. Now the 16 will be also moved to the period activities. So we will move the 16 here, and as we did previously on the left to right path. So we will move the latest finish time from the period activity into the successors or the preceding activities. Now we subtract the 16 minus 4, and we will get what? We will get the 12. So we'll type 12 here. And we will subtract the 16 minus 2 here, and it will lead us to 14. So now we completed G and F. The same for D and E. They will have the latest finish time transferred from activity G. So we'll have 12 here and 12 there. And we subtract 12 minus 7 will lead us to 7 again, and 12 minus 1, it will lead us to 11. So we type 7 here and 11 here. Okay. Now, moving on to activity B, we will come to C after we finish B. So moving to B, we will have the same latest finish time from activity D transferred to activity B, which will be 7. And when we subtract it from 4, it will be the 3. Now, for activity C, we have a different situation. We have two activities as a successors to activity C, which are they E and F. E and F has different values in terms of the early start time. So which one we will take in this case? We will take the least one, or the minimum one, or the smallest one. So we will have the 11 placed here, and we subtract the 11 minus 2, it will be 9. Now, again, for activity A, we have two successors, which are they B and C. And we select the minimum one, which is the 3. So we will have 3 here, and 3 minus 3, that would give us 0. So by this, we have finished the second or the third step after we have placed the tables or the matrix instead of the letters. Now we have, and then we did the left to right calculations for the early start time and early finish time. Now we have done the latest start time and the latest finish time, which is the right to left calculation. Now we will proceed with the coming step. After we have done all those, we will have to calculate new variables or new indicators that will help us to proceed and find the critical path. Those two variables are the total float, which is referred to TF, and the free float, which is referred, or the abbreviation for that is the FF. The total float is the least finish time minus the earliest finish time, or you can do the least start time minus the earliest start time. The least, finish time, here it has to be LFT minus, yes, it's correct. The least starting time minus the earliest starting time. Yes, correct. So either the finish time or the start time, you subtract them from each other. This will help you to identify the critical path. The free total, the total float will help us not only to identify the critical path, but also will give you the room where you can have more time in some tasks, so it will not affect your end project. Whereas in the free float, which we will calculate it later, it will give you another indication for the values for each activity where you can be delayed, but how that delay, it will affect the early start time for the coming activity. We'll come to that, but let's start with the total float, because this will help us to at least complete the first part, which is calculating the critical path and identifying the critical path. This is the first part of the activity network diagram. So how we do the total float, we will subtract either the start time columns or the finish time column. And to proceed with that, so here, let's say we are going to take the finish time. In this case, both of them, they will give you the same answer. So we have 3 minus 3, which is 0. and here 7 minus 7 for activity B will give you 0, and 12 minus 12 for activity D will give you 0, and 16 minus 16 will give you again 0, and the same for H will give you 0. For activity E, you have 12 minus 6, which will give you 6, and 11 minus 5 or 9 minus 3, either one of them, it will give you 6 also. Now, for the 16 minus 7, that will also give you 9, I believe. 16 minus 7, yes, that's 9. So this is, we have completed the total float for the activity network diagram. How we identify the critical path? By looking to the activities, they have zeros as a value of the total float time. And in this case, we can see that the activity from A to B to D, and then from D to G, and then from G to H is the critical path. And what does that mean? There is no room to be delayed at any of those tasks. Any delay on any one of those tasks from A to G, it will affect the end time of the project. So those tasks are very critical. This is your bottleneck. This is where you have to consider there is no room for delay in those activities. Whereas in these activities here, C, E, F, there are room to work on. You have a room of 6 days in this case. If you have completed the task instead of the duration that given one, you have even more. So you can have more time than the specified time to complete those tasks without affecting the early start time for G. For example, if you have the early start time for this activity was 5, and you finish it after 2 weeks instead of 1, you still have finished it at 7, which is earlier than the early start time for activity G, and that will not affect the end time of the project. The same for activity F and activity C. We will work on the free float and see how the free float also gives you another information in terms of the resources or the time duration you have for every task. So to answer the first part of the question, what is the critical path for that given activity? In the table, the critical path is given, or is, excuse me, A, B, D, G, and H. So those are the critical path. And the project duration for the critical path is 19 weeks. Any delay in the critical path will affect the whole project duration. Okay, this is the first part. Now we come to the second part, which is the free float and how we calculate the free float. Let's go back to the formula here and see how we calculate the free float. The free float is the early start time for the successor minus the early start time for given activity minus duration for given activity. How we interpret this? What successor means the activity that comes after the activity you are working on. So let's say we are working on on activity A. Give me a second, please. Okay, let's say we are working on activity A. So the successor for the activities that comes after activity A, which are they B and C. So in this case, what are we going to do? We have to take the early start time of the successor. The early start time of the successor here are equal, and in case we will come to that point if they are different, so don't worry about it. Now we will take the early start time of the successor. So we have 3 here is the early start time for the successor. So that will be minus the early start time for the given activity, for the activity where you are studying. So we are studying A. The early start time for A is 0, minus the duration of the given activity. The duration of the given activity is 3. So basically what you will do as a free float equal 3 minus 0 minus 3, and that equal to 0. You see it here. This is the free float for activity A. The first 3, which is the early start time of the successor, minus 0, which is the early start time for activity A, minus 3, the duration time for activity A. Moving on to B. So let's work on B. What is the early start time for the successor, which is D, is 7. 7 minus 3, the early start time for B, minus 4. So 7 minus 3 minus 4, and that also will give us another 0. So that will be 7 minus 3 minus 4, and that equal to 0. The same we will do on the coming activity or the preceding activity. On activity D, we have the successor is G, and the earliest time for G is 12. So 12 minus the early time for D, which is 7, minus the duration time, which is 5, and that also will give us 0. 12 minus 7 minus 5, and that gives us 0. The same we will continue, and we will have the same here for that as a 0. And now for let's move on here. In this case, also the earliest starting time for the activity E is 5, and the early start time for C is 3, minus the duration is 2. So 5 minus 3 minus 2, and that will give us also 0. For E, we will have the 12 minus 5 minus 1. So it will be 12 minus 5 minus 1, and that will give us 6 as the free float. For activity F, we will have 16 from activity H as the early start time, minus 5, the early start time for F, minus 2. So 16 minus 5 minus 2, which will lead us to 9. So 16, let's type it here. 16 minus 5 minus 2, and that will give us 9. Okay. This is how we calculate the free float. And what does the free float mean? Let's go and highlight those notes, and please pay attention to those notes here in this slide. This slide is very important, and it explains a lot of maybe the questions you have in your mind now. The total float and the free float, which we just calculated the total float that in the top of the box here, as or the top of the table or the matrix, we always refer to it in the top here, and the free float we refer to it the value that under the table or below the table. We refer to those values as the slack of the activities. The total float that we calculated on the top help us to find the critical path, as well as to know the time you have for every activity, that even if you work with this time, it will not change your end project time, as we saw in case of the activity E, as we saw in the activity C. So the definition of total float is any amount of time for given activity, like activity A or B, can be delayed without affecting the end date of the project, considering that the task started on its early start time. So here, this value give you the information about, or the value or the time duration you have to finish this activity E without affecting the end of the project. But you have to consider that you are starting on the early start time, because if you are going to start instead of 5, you are going to start on week 6 or week 7, then you have to consider that this 6 will not apply, because that will be add up. So if you have time as it, and you added the value of the TF, which is the total float, it will also give you the enough room to finish the project on time without any delay. The free float, on the other hand, which is the values below the tables here, give you the amount of time for also every or any given activity, how they can be delayed without affecting the earliest time of its successor. So the 6 weeks we have here is the 6 weeks that you have to, you can delay activity E without affecting the successor, which is activity G. Considering that the delay on the late starting time for given activity will affect the successor. So the late start time, if it was not as here as 11, so this 6 will not be considered. In this case, the one we have drawn here or calculated, you have 6 weeks if you are going even to start on the late start time, which is 11, and you still can finish without affecting the early or the beginning of the or the late start time for the coming activity. So sorry, for the earliest start time. So we consider the 6 and the early start time for the activity that will not affect the late start time for the coming activity. Always the early start time here considered. Why? Because if we are going to consider the late start time, that also will affect the early start time and the late start time for the successors. So that will tells you how much time you have to delay this specified activity without affecting the late start time for the successor. And the top one, it will give you the time you have to proceed with this activity and start with it without affecting the end time of the project. Okay, you can see here in some activities they have here a 0 free floating, like in activity C, and that tells you you cannot have, or you cannot delay that activity by 1 week, because that will affect also the beginning of the activity on the successor. And how that will work. Imagine if you have here, let's say you started on the 3, or which is the week 3, and you have the duration is 2, and that will be 5, okay, for the coming successors. If we have the latest time, which is the starting time, is 9, and you have already proceed with that more than the duration time here, which is you have like 3 instead of 2, so that will be 12, will not give you enough time to proceed with the successor, because the starting time will be 12 plus to the 19 plus to the 9, and that will give you 21, so you will be delaying the project. However, this here, it will not affect the completion of the project, but here it will affect on the total floating. It will not affect the completing of the project here time. But when you see this one, you have to consider it will affect the earliest time of the successors. Now, depend on the successor. Does it have enough time to complete the task? Does it have enough resources to complete the task? Then you have to look up and watch this value here. Do I have enough time if I delayed the C, that I still can proceed with the F within the duration I have, the 2, or no? So those are like indicators, and gives you how each activity will affect the end of the project, and how each activity will affect the early starting time for the coming activity. And then it will up to you how you manage this slack values. Because here in our case, we have those 3 activities where we have the room for room of time where we can delay some tasks. But here in activity A, B, D, G, and H, we cannot even be delayed to those tasks, because it has to be starting on time, otherwise it will be not completed on the time for the project or for the task you have. And that's why here we have to keep the 16 all the time coming from the activities G and F. In our case, the G is already fixed, we cannot change it, and all the path here it will not affect, but the activities can affect the early starting time for H is F, and F is depending on the C. So the changing here in the activity finish time, or the processing time, if it is exceeding the time that is we calculated from the free float, it will affect the early start time for the F. And then we have to consider if the F have enough time to complete the task without affecting the end of the project or no. And that will tell us from here, from the beginning. So we already answered this question when we calculate the TF. The TF tells you that you have 6 weeks of duration to complete this task without affecting the project end time, but with the consideration that the duration of time we have more than the specified one, which is the 2 weeks, it will affect the beginning or the start time for activity F and activity E as well. So for both of those activities, the start time will be affected. And now it depends on those, how they have total float and free float in dealing with that delay. So this is very important values just to let you help you how you manage your tasks and how you can manage the delay in some tasks and how you can be strict in finishing some other tasks on time so you can stick to the overall project duration. There are also some notes that I highlighted here in the corner of the page. The free float always equal or less than the total float. Meaning, if you have already the total float is already calculated zeros, so you don't have to calculate the free float and it will be equal to zero, the same, because it can, if it is zero, that means either it will be zero or below zero, which is zero in our case. But for those total float we have here more than zero, you have to calculate it, but also for a verification, the value of the free float, it will not exceed the value of the total float. So this is a verification point to make sure that your calculation is correct. If a case in free float you have more than one successor with different early start time for each successor, you choose the successor with the minimum early start time. Remember this example or this case. When we were working on activity A, and the early start time for B was 3 and the early start time for C is 3. Let's say they were not 3. Let's say the early start time was 5 and here was 3. So you will select the 3 in your calculation for the free float. You will select the minimum in the calculation for the free float, similar to the calculation of the late finish time when we do the right to left calculations for the activity network diagram. That was all for this tool. Moving on to another tool, and it's very common to be used in project, and most of the big project they develop this tool. Even in the capstone design project, it's required from students to develop the Gantt chart. Gantt chart is a very simple tool. It helps you to represent the time into in bars, or looking like bars or lines. Where is the start time? It shows you where is the start time and the finish time for every single activity or task in the project. For example, here we have example for the Gantt chart, how activities or what activity needed to complete the Fit Sigma program in our course. So you need these activities to be completed. Each activity, you have a start and end time. Now the unit of time, again, as we talked in the activity network, it can be either weeks or specific days like 17th of June 2021, or a specific day and time, or years or quarters, depend on your project and your plan. It can be like for your capstone projects on specific days, or weeks again, because the semester weeks. Some tasks, they will overlap, and that also can work together. This tool can work together with the activity network diagram to evaluate the critical path in your project. And here you can see the overall view for the tasks. Here there is an optional, sometimes they add resources for each task and they sum up those resources vertically to calculate the total resources needed for that week. In some project it applies. For example, you need some 2 people to work on this task or activity B, and you have 6 people, they need to work on that activity. So on that week you have to consider 8 people, they will be working on two different activities. So you have to utilize your resources in terms of the people are working. It could be tools, it could be equipment, it could be any type of resources. It is optional, some they use it. Also, the description again for the activity is recommended to be written next to it, so anyone look to your project know what do you mean, or a legend key box for each activity. What does it mean, and what are they? The last not least, in our control phase, the PDCA tool, which is the one already covered earlier, but today we'll give more information about it and talk about small example and an easy example how it works. PDCA, or the Deming cycle, is very commonly used in continuous improvement. So consider to be a tool itself as a quality improvement method, because it keeps the improvement uninterrupted all the time, is continuously is running. So it's a practice itself, whether you use it for a control phase in the make or you use it in separate. It's a cycle that is proved that to be commonly wide and successfully implemented. There is another version of that, they call it the BDSA, which is plan, do, study instead of check, and both of them work with the same concept. The most common they refer to it is Deming cycle or Deming wheel. Enables you to two type of corrective action, either the temporary or the permanent corrective action. The temporary is to fix the problem that you have right now, and the permanent is to identify the root causes and make this improvement sustainable, and consistent investigation will be conducted in the process to keep that improvement going over and over. Or it can be, as we said, as a temporary, just to solve the problem and close that project. So it works in the both ways, either for the long term or for the short term. An example here, or before the example, let's define each phase, what is the major steps or what is the major tasks needed. In the plan phase, you need to define the problem, and you have to collect the relevant data and be certain about what is the problem or the root causes of the problem, and then do develop and implement this a solution. Decide upon the measurement, so also you collect the measurement of your improvement. In the check, you confirm your results or your measures of the improvement with the before and after, so you make sure that you have done an improvement and progress or no. In the act, you document this result and inform the others about the process and make the recommendation for the problem to be addressed in the next cycle of the BDCA. Now, as we say, depend. If you are going to work it in a temporary project just to solve a problem and resolve it, it will be just documenting the results and write the recommendation, and then there is a next cycle will come later if it's needed or no. Or it could be a permanent, so this cycle will be going over and over and over with non-stop. As we will see now in the example here, this is, I brought it from our life here in the school, when we implement the BDCA as a continuous improvement for teaching IE courses in the IE Industrial Engineering Department. The plan is you prepare, as an instructor now here, you prepare course material, you prepare the slides, the exams, the lab experiment sheets, all other materials that external materials, resources need to be reviewed, all that you prepare it as a plan phase. Consider the previous recommendation. If this is a permanent here, in our case, permanent implementation of BDCA, so you consider if there is any previous implementation and there was any recommendation to be considered. For the do, you deliver the lecture as you have planned for it. You conduct the lab experiment as you plan for it, and the same for the exams. and you collect the performance measures for those students' achievements and students' performance in the class. And then in the check, you analyze the students' results and you compare these results with the previous semesters, and you see how is the performance of your students. And then in the act, you document this analysis and findings, and also you provide recommendation to improve the students' performance in the coming semester based on that current semester results. So this will keep going over and over, and this is happening here in the department in all the courses, and it's reviewed every semester. So this is a simple implementation of a plan, do, check, act concept, or the Deming cycle. By this, we finished today the tools for the control phase. There are also in the Six Sigma review recorded session other maybe tools you see for the control phase. As we said, control charts, run charts, and check sheet, and many other tools also can be fit to this phase usually, but it's very important to recommend your results to document, sorry, your lessons learned and results, and write the recommendations for the organization to maintain the improvement you have showed in the previous phase, which is the improve phase. I hope you enjoyed this session, and see you in the next session.